In this video, we're going to be looking at topic 2b, the halogens, which are group 7 of the periodic table, and this is for the IGCSE chemistry course from Edexcel, and we're going to be focusing on the double content in this topic. So for double science, you need to know the colours, physical states and trends and properties of group 7. You should then be able to use these trends to predict the properties of other halogens, and also how displacement reactions involving hydrogens and halides provide evidence for the trend in reactivity. So the halogens are group 7 of the periodic table, and they are fluorine, chlorine, bromine, iodine and astatine. Now the ones that you will focus on most in your exam would be the first 4. So fluorine, chlorine, bromine and iodine. If you are asked about astatine, it is typically a predicting properties question because we don't know that much about astatine, but we will come back to that later on in this video. So let's have a look at some of the physical properties of the halogens. They share similar physical properties and they show a trend as you go down the group. So just a reminder that the word trend is another word for a pattern as you go down the group. So what we see if we look at the melting and the boiling points is that they increase down the group. That means that the halogens at the top are gases, so you have fluorine and chlorine, but near the bottom they are more likely to be solid, for example iodine and astatine. Bromine is a special element because it is one of 2 which is a liquid at room temperature on the periodic table. The other one being mercury, and you touched on this back in the periodic table topic 1D, but of course we're not going to discuss mercury here because it is not a halogen. The halogens are also poor conductors of heat and electricity, and their colour gets darker as you go down the group, and we'll look at the colours in just a minute. And most importantly, the vapours of the halogens are extremely poisonous. So you do not ever want to be breathing in any of the vapours of the halogens because they are very poisonous. So we can see that fluorine and chlorine are our gases, and bromine is our liquid and iodine is our solid, and that is to do with the melting and the boiling point increase. When we look at colour, fluorine is a pale yellow colour. Chlorine is a pale green gas. When we get to bromine, the colour becomes a red-brown liquid, or if it is the vapour, it is an orange-brown colour. And iodine is a grey solid, but when it turns to vapour, the vapours are purple. So you can see that we are getting a trend of darker colours down the group. So there are a few key reactions of halogens that you need to know for this topic. The first one is the reaction that they have with hydrogen. So they will react with hydrogen to form a hydrogen halide, and that could be HF, HCl, HBr, or HI. And each of these hydrogen halides are poisonous, acidic gases. Okay, so they are not particularly good. They are toxic, so we don't want to come into contact with them, which is why we said that you should never be breathing in the vapours. But most importantly, we can then dissolve these gases in water and they will form acids. So if we look at an example of hydrogen reacting with chlorine, we are going to make HCl with the state symbol of G. When HCl has the state symbol of G, we call it hydrogen chloride. And that is, of course, a gas. Now, when we take that same hydrogen chloride and we dissolve it into water, the state symbol does not change. It is still HCl, but the difference is we now call it hydrochloric acid. So please be aware that depending on the state symbol, you will have a different name for the hydrogen halide. So always check that. That's a common exam question that they like to ask. Halogens can also react with our alkali metals and they will form ionic salts. So for example, sodium reacting with chlorine to give you sodium chloride. and we discussed that briefly in topic 2A when we were looking at the alkali metals. They can also react with non-metals, and that will form a covalent compound, but we don't need to go into too much detail about those reactions. The only one that you have to be able to know is the formation of the hydrogen halide. A key point for double science is the displacement reactions that can happen with the halogens. So a displacement reaction is a reaction that occurs when a more reactive element or a more reactive halogen takes the place of a less reactive halide ion in a compound. So as we go down the group, our reactivity decreases. So this is different to the alkali metals. In the alkali metals, we saw the reactivity increasing. For the halogens, it decreases. And if an element is more reactive, it wants to form an ion. So it is more likely to gain an electron to form an ion, and the less reactive element would prefer to exist as an atom. And a displacement reaction takes advantage of this. So, for example, if we take bromide in the compound potassium bromide, and we react it with a more reactive halogen, so remember our order was Cl, Br, and then I. So if we take these bromide ions and we react this compound with chlorine, the chlorine is going to displace the bromide ions, and that would then form potassium chloride instead of potassium bromide. And we would see the solution turning orange because we are forming the bromine. So we would see a colour change happening here. This would be a colourless solution with a pale green gas. And as the bromine is forming, it is dissolved into the potassium chloride, and we would get an orange solution. If we have iodide ions, for example, in potassium iodide, and again we react it with the chlorine atoms, we are going to get a displacement reaction. And this time we're going to form iodine, and again potassium chloride. And because we are forming iodine, we see a brown colour in our solution, because iodine is a dark grey solid, but its vapours are purple, so the colour when it is a solution is somewhere in the middle, so it's a kind of deep brown colour. Now when we're looking at what can displace each other, we have to look at the position of the halogens in the periodic table. So as we go down the group, we start from fluorine to chlorine to bromine to iodine, and a halogen can only be displaced by something that is above it on the periodic table. So because there is no halogen above fluorine, it cannot undergo a displacement reaction. However, it will displace all of the other halogens because it is the most reactive. Chlorine only has one halogen above it, which is fluorine. So fluorine can displace chlorine, so take its place in a compound, but chlorine will displace everything below it, so your bromine, your iodine, and astatine as well. Bromine is in the middle, so it can be displaced by the two above it, which is fluorine and chlorine, but it can displace the two below, which is iodine and astatine. Iodine is typically the one that we would say is the least reactive, because we don't really talk that much about astatine. So out of the four, it is, we would say, least or less reactive. So iodine can be displaced by everything above it, which is fluorine, chlorine, and bromine, but the only one that it could displace would be astatine if it was in a compound. But as we said, we don't talk too much about astatine, so it tends to be the iodine doesn't displace anything. Now, displacement reactions are examples of redox reactions, which is a reduction and oxidation. You will learn a lot more about this in topic 2D, which is the reactivity series. So don't worry too much about this just now. Oxidation and reduction is to do with the movement of electrons. If a substance loses an electron, it is said to undergo oxidation. So in this case, the bromide ion is losing an electron to become a bromine atom, so it is being oxidized. And the chlorine is gaining an electron to become a chloride ion, so it is being reduced. And if a substance is being reduced, we call it an oxidizing agent. Whereas if a substance is being oxidized, we call it a reducing agent. Now that might seem a little bit backwards, but if the substance itself is being reduced, for example, the chlorine is being reduced because it is undergoing reduction, but it is causing the bromide to be oxidized. So when we say an oxidizing agent, that means it is causing something else to be oxidized. Now don't worry too much about this at this point. As I said, we will go back over this in topic 2D. So to summarise the properties of group 7 that you should know, well, we know that they are typically diatomic because 4 of our 7 diatomics are in the halogens, so fluorine, chlorine, bromine and iodine. We go from gases to liquids to solids down the group because we have an increase in our melting and boiling points. They are coloured poisonous vapours, and the colours get darker as you go down the group. They can form compounds with the formula HX, and X is just any of the halide ions, so fluoride, chloride, bromide and so on. And they form these when they react with hydrogen, and we can dissolve these in water to form acids. They can form ionic salts with metals and covalent compounds with non-metals. When they form an ion, they will form a 1 negative ion because they are gaining 1 electron. And we've talked about that when we did the ionic bonding topic. They become less reactive as you go down the group, and they can displace elements that are lower down in the group. So the higher the halogen is in group 7, the more likely it will displace something below it. So we can then use that information to predict the properties of astatine. Astatine should be darker than iodine. It should be a solid at room temperature. It should be diatomic and will react with hydrogen to form HAT, and that should dissolve in water to form an acid. It should be able to form ionic salts with the alkali metals. They should contain astatide ions, which should be AT-. It will be less reactive than iodine, and it can be displaced from solution by iodine, and it will not displace anything else because there is nothing below astatine on the periodic table in the halogens. So let's finish off by looking at a past paper question. So bromine, chlorine and iodine are elements in group 7, and we want to place ticks to show the 3 correct statements. So first statement, elements can be obtained by electrolyzing molten metal halides. Don't worry too much about this. This is probably more likely to be in triple, but this is from the old specification. That simply means that I can take a compound like NaCl and I can pass some electricity through it, and I will form sodium metal and chlorine gas. And that is a true statement. For the second one, elements are paler with colours as they go down the group. Well, we know that that's wrong because we know the colours get darker. The boiling points will decrease down the group. Again, we know that is wrong because we know they increase. They will form covalent compounds with other non-metals. Well, that is correct. Their molecules will contain 2 atoms, so bromine, chlorine, and iodine are all, of course, diatomic. So that is also a correct statement. So that should be our 3, but let's just check the last one. All gases at room temperature. Well, chlorine is a gas, yes, but bromine is a liquid and iodine is a solid. So we know that that one is wrong as well. Part B says group 7 elements are called halogens because they react with metals to form salts. Write a chemical equation to show the formation of the salt potassium iodide. So potassium iodide is going to have the formula Ki. We know we must be reacting the metal potassium and we're reacting it with iodine. Iodine being a diatomic should be I2. And of course, as GCSE students, you should be able to balance this. So if I start with 2 iodines, I have to end with 2 iodines. So I need a coefficient of 2. And that tells me that I end with 2 potassiums, so I must start with 2 potassiums. A nice easy balancing there. For part C, the equation for the reaction for hydrogen and chlorine is H2 plus Cl2 gives you 2HCl. And the hydrogen chloride and hydrochloric acid are both represented by the formula HCl, but we have to put in the state symbols. So remember, hydrogen chloride is when it is a gas, and hydrochloric acid is when it is aqueous. So make sure that we get those the correct way round. Now, halogens can take part in displacement reactions with halides, and the table gives information about the addition of halogen solutions to halides. So we have bromine being added to sodium iodide, chlorine being added to sodium chloride, and iodine being added to sodium chloride as well. So part 1 says, which test cannot be used to compare the reactivities of the halogens? Well, in order to compare the reactivities, you have to use different halogens. So if we look here, we have bromine and iodide. That's perfect. For the third one, we have iodine and chloride. So that's okay. But for the second one, we're using chlorine. So the one that will not work is test number 2. And that is because chlorine does not react with chloride ions. It cannot displace itself. For part 2, which observation shows that a displacement reaction occurs in test 1? Well, let's go back, and it says for test 1, we're showing a displacement reaction. So we have bromine being added to sodium iodide. So Br2 being added to NaI. Well, what should we form? Well, we should make NaBr because we're having the bromine take the place of the iodine. And we should form iodine solid. So we should see, could it be A, effervescence? Well, no, we're not seeing any gas being formed here. B, purple fumes appear. So whilst we do have vapours of iodine that could be purple, there aren't going to be any vapours here because this is going to all be aqueous. So the solution becomes darker. Well, that's going to be our answer because as we form our iodine, that's going to have a darker colour, so our solution is going to get darker. And lastly, astatine is an element in group 7 that could also be involved in displacement reactions, and it gives us the ionic half equations, and we want to write an ionic equation. Now, we will revisit a question like this in topic 2D, but we can actually still answer this question even now. What we need to do to write this equation is we need to combine everything on the left-hand side and everything on the right-hand side of the arrows. And what we should also do is there should be no electrons. We always remove the electrons here. So you can see that on the left-hand side I have 2 electrons, but I also have 2 on the right-hand side. So actually, they cancel each other out. So I simply rewrite what is left. I have Cl2 plus 2 astatide ions are going to react to make 2 chloride ions plus At2. And you can see that the answers are there as well if you wish to check them against what you were doing if you were answering the questions yourself. That's everything for topic 2B, the halogens, for double science. If you have any questions, please feel free to leave a comment below, and we hope to see you back soon.